Alright, welcome back to the channel. For today's video we have another U5000 that is vertical collapsed. This was sent to me in effort to get it repaired because the original owner either didn't want to mess with it, or didn't know how, or tried, or did, I forget the exact scenario, but it was sent to me because it needs repaired. So again, we have a U5000 here, vertical collapse, and I'm not going to actually power it up to verify because I already know it's collapsed. I'm going to put a picture here right after this so you can see exactly what it's doing, and you can see that it's actually collapsed right now. And I'll take it out of the box here and we'll inspect it. So let's go ahead. The other side has the owners and the shippers my information, so we're going to open from the bottom side here. Okay, definitely U5000. Here's our vertical sweep mod that should be attached to the heatsink for the vertical IC, and it's not, but that's common. Alright. Ooh, what is this? That's not right, or normal. These two power diodes here. What the hell is going on here? Huh. I gotta say, that's the first time I've ever seen that before. We got these two power diodes. I need to take all that apart to see what it's going to, but it looks like it's in line with R304 here. Interesting. Well, we'll take a look at that a bit closer, but yep, it's definitely a U5000. We've got we had some noise when I put the box away. I had some noise floating around in the box. Let me get the box and make sure nothing's floating around in there. We got another interesting thing here. Is I don't recall ever seeing a 5000 with this wire here for around the flyback ferrite, because this is usually for a blanking mod, if I'm not mistaken, but this is on the 7500. I've never seen a U5000 with this on there, so that's very odd as well. I mean, we'll leave it there, but that's just very odd. So is this. I don't know what this is about, but oh well, I think I found the problem. Look at this. We got a diode cracked in half. Well, if that's the fix, that was easy. I think this is D302, if I recall correctly. Yeah, this is just cracked right in half. Look at this. Yeah, D302 is broken right in half. Well, no real need to check much else, but we will. Let's see. Let's see if our 25 volt reference point is not on this one. This one, the reference point is right here. It says 30 volts, but it's 25. This is the 25 volt reference for the vertical IC, and this is where you test to make sure you're getting 25 volts. But I can guarantee you 100%, with this diode being split in half, we don't have that 25 volts over here, which is why we have our vertical collapse. Now, why this split in half? That's a mystery. I can't say that's ever happened that I've seen. They just short or open up, but I've never seen one completely open up literally. So that's quite interesting as well. It looks like somebody has previously capped it, so I'm not really going to mess with that. Obviously it worked. It's just collapsed. Let's zoom back out, sorry. And we'll check the usual suspects like all the solder joints on the video selector, because somebody reflowed. They reflowed the one here for the medium res, but they did not reflow the one for the standard res. You can clearly see that somebody has reflowed this one, but not this one. And as a matter of fact, we got a couple of joints here, especially this one, that's right on the verge of cracking completely. So we'll take care of that. Overall, the bottom looks fairly good. Someone's done a bit of a jumper here for a cap that they damaged the trace on. And there's another damaged pad here. This guy right here is that off of a capacitor? Yeah, that's off of, yep, look at this here. Wiggle, 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 wiggle. Are they actually broken? No, the traces aren't broken, but I'll still have to fix that. There's a bunch of this mess going on here. Not sure what that's about. Well, we need some reflow, not a big deal. But first things first, let's see what was making noise in the bottom of this box. Well, it's this thing. And this goes in here, like so. So that just came out. This got smashed a bit, but they look okay. How are we looking on our, well, these got smashed too. I'll do all the normal reflow and work that I do on this. Not going to be an issue. The neck board looks fairly good. A little heat soaked, but everything looks good as far as the pads and the solder. Nothing is too oxidized, but we'll still reflow it. And I need to rework all of these heat sinks because they're too close to each other and they induce heat onto the other ones and make them even hotter than they should be. So let's do the normal thing here, and we'll set all these to center like I always do, just for testing. Roughly there. Roughly there. Blue was 100% down. That's interesting. Everything's interesting. Alright. So, let me get a donor chassis. Gonna have to go grab a donor chassis and replace this D302, and then we'll start going through and testing all of our other stuff. R302, I should say R303, I'm sorry, this guy right here. If R303 is open, that'll cause it. So we'll go through and test everything, and I'll talk about, again, what can cause collapse, vertical collapse if it's, let's just pretend like this dial was intact. We'll pretend like this dial was intact, and I'll go through and test everything else as if it was good, and we can see if we'll find anything else in the circuit that's bad. So, alright, that's just, I've never seen one split in half like that. That is quite interesting. So let me grab a donor chassis. We'll rob a D302 from that, and then we'll see what else might be wrong and do some testing and reflow, and then we'll do a final op check. So stand by one moment. Okay, so I've got my donor U5000 here that we can do our testing on. And by testing I mean pulling components off of and use for this one. So let's get this D302 out of the board. Wait for my iron to heat up. Sorry, I'm not prepared here. Okay. It's going to be this one. Any day now, iron, any day now. All right. What is your major malfunction? That was harder than it needed to be. Alright, so here's our diode. Removed successfully. Let's get this other one out of here. And what I'm going to do here is take all this other ancillary junk off because I don't need it to be hooked up while we're doing this. Neck board is out. Remote board is out. Alright. Let's grab this piece. I don't think it'll be as easy as I'm wanting it to be here. There's one half. There's the other half. Well, that was surprisingly easier than I expected. Okay, where is the microfilm? The microfilm. Okay, holes are nice and open. Here's that diode, split in half. So in the trash it goes. Let's get our new one, make sure it reads good. Probably could have done that before we took it out, but I'm sure it's fine. Okay. Here we go. Oh. There we go. Oh, come on. 0.453. So we got a good diode. Let's straighten the legs out. As much as I can. And see if we can line this up here. Well, damn, that went right in. It's about the easiest diode installation I've ever done. Right in, okay. Gonna stay there. Alright, our diode's installed. Now I want to check this first to see what the heck's going on there. And let's go to ohms. And this should be roughly 10K. 13K, that's kind of high. It should be okay, but that's pretty high. What these diodes are doing in here, I don't know. I'm not going to remove them because it doesn't affect vertical collapse, whatever this is, but that's just something that I've never seen before, and it's quite puzzling. I don't know why they would have that there. It's going across. Oh, I see. Okay. There's a diode here, D302. It's normally right here, this diode. You can see here on this setup that it's missing. And somebody has apparently put it on the bottom side. And why they did it like this, I don't know. But it's not something that I did, and if it's working, I'm just going to leave it. It's a very odd thing to do. Why you wouldn't replace it or repair it correctly, I can't say, but at least we've kind of solved that mystery. So we're not going to worry about that now. So if we go to R303, yeah, it should be 1.2 ohms. If R303 is bad, it will cause you to not have your 25 volt reference at the vertical IC. So we'll check that, and we have 4 ohms. That is very close to being out of tolerance. I think I'm going to replace that. Well, let's wait a minute. Let's see what this reads if we give it time. 3.9, 8. What does it read out of circuit? Out of circuit 4.3. See, that's not right. It should be 1.2. I'm going to replace that. 4.3 is not something I'm happy with on that. Let me see if I can find one, because my donor one doesn't have one. It's been robbed long ago. So let me see if I can scrounge around and find one. Hold on a second. Alright, so I found one that's about 2.4, which is much closer. And once it's in circuit, it should be closer down to about 1.8, which I'll be happier with. Let's go ahead and test the old one again. Yeah, 3.8. I don't like that, so we're going to put that away. This one here is 2.0, 1.9. So it's going to be even lower in circuit. So for just testing purposes, if we actually just slave it in here on the back side without soldering it in and put pressure against it while we test it so it touches the pads, we're at, well, I'm not sure I'm touching the pads here. Let's do it this way. 1.8. I thought it'd be a bit lower than that, but I guess not. Either way, 1.2, 1.8, that's a lot better, a lot closer than 4.0 or 4.2, whatever this one was. So yeah, I'm much happier with leaving this one in here. It's the same rating, same tolerance. Not same rating, I'm sorry. Same tolerance, same wattage. So we're going to be good putting this in here. So let's do that. Okay. So far we've had a out of tolerance R303, and we've had a busted or blown open D302. So those have been replaced and the diode's incorrectly. So now let's go through and do the rest of our testing here. We know it powers up, so I'm not worried about it, the power circuit. And the medium resolution, another problem is that it was on medium resolution setting and this was plugged in. It is not supposed to be plugged in for medium resolution. On the medium resolution setting, you get to take this black, there's a black wire that's cut off. You want to put the pin on the black wire portion. So when you have it on standard or medium resolution, you want to have that black pin hooked up. On the standard resolution, you want to have the white wire hooked up. So this needs to be hooked up for standard and not hooked up for medium. Do I have that right? I think that's right. We'll find out. It's one or the other. I can never recall exactly. Let's put some of this stuff out of the way, declutter the area. Actually, you know what? Let me go verify. I have to get a tube anyway to test this. Let me get the tube and verify that I have that correct before we kind of proceed here. Hang on. So I was absolutely correct. You do not want to have this hooked up for 25 medium resolution, and you do want to have it hooked up for your standard. So you want to have the white wire hooked up to the pin for standard, like so. And for medium, you want to take it out and move it over to the other one so it's not hooked to anything, just that black wire that's in there. So yeah, I think when I took this out of the box, if I recall, it was hooked up. So that might have been problem number 2. I'm counting, well, I guess 3, because this will be problem number 3. R303 being out of tolerance was problem number 2. Problem number 1 was D302 being exploded. So now that we got this set correctly for the medium, let's go through and set this on here so my metal workbench doesn't give us false readings. We're not worried about power section. I have a number of videos on this already that teaches you how to test the items in the power section. Since we know it powers up, I'm not going to be worried about that. So next would be this resistor here, R760. Make sure R760 is good. 480 ohms, that's good. Alright, and then we got this one here. Which one is this? I don't have these memorized. R619 it looks like. Make sure that's good. And 81 ohms, that's good. R620 is it's 650 ohms, give or take, that's fine. And then we'll test our diode. There's a diode in here, D303. You want to put negative on the anode, or is it cathode? I forget. The side with the stripe. Negative on the side with the stripe, go to your diode checker. Positive on the side without the stripe, and our diode is good. Now, here's a very quick and easy way to test if your vertical IC is bad. You see how we're reading correctly on this diode? If we flip our leads around and we still read like a diode, see, our vertical IC is most likely bad. You should not be able to read both ways. You can see here if I take this one and do the same thing. Now the vertical IC is not installed in this one, but you'll see that if I actually test this one, our diode's good. If I swap the leads around, it doesn't read backwards. So usually if you have D603 is reading both ways, you got a bad vertical IC. So I'm hoping that's not the case. I think I have one left. I do not have one. Well, that's unfortunate. If we go through and do all of our testing and it turns out that the vertical IC is bad, I'll have to order one, which will be immediate for you guys, but it'll be a couple of days for me. So let's go through and make sure. So our D603 is good. We didn't check our D302 in circuit, which I guess we could do now. That's good. Yep, and R303 1.7, that's pretty much perfect. What is this one? That's, yep, I think that's supposed to be 1.2 as well, but it's close enough, this one here. I'll say that's okay. Alright. There's another one that was damaged. That's what that speaker wire's doing. Interesting. Not sure if it's supposed to go there, but I'll fix that the proper way. Okay, well, let's test to make sure our vertical IC doesn't have any pins shorted to ground that it shouldn't have. And I'm pretty sure that this pin here is the only one that should be ground. It's pin 5. And let me zoom in. You'll hear if I touch the leads together. So we're good for that. So if I go to ground and I touch pin 5, that should be our only ground. We should not have any other pins that read to ground. 1, 2, 3, 4. Well, that's bad. There's our ground. There's pin 6, 7, 8, 9, 10. Pin 6 is reading to ground. It should not be. So I think we're going to have a bad vertical IC, unfortunately, and that's very likely because, again, we had our sweep mod installed when it was set to a medium when it shouldn't have been. So that's problem number 4 now. So let's see, pin 6 goes to across this, so that's not shorted. So the only real way to do this is to remove the vertical IC from the circuit, and if 5 and 6 here are shorted together, dead short, 0. We have to take the vertical IC out of the circuit, and if pins 5 and 6 are no longer shorted, the vertical IC is bad. And we're not going to be able to really do any testing until I can replace it. I may have one, I may not. So I have a couple other donor chassis here that I can possibly rob one from, but I'm pretty sure I've already robbed them all over the years. Yeah, so let's go ahead and just get this removed. And I'm not going to use the desoldering station. We're just going to use the old braid method here. Okay, it shouldn't be too difficult here. Alright, so now I'm hoping that our pins 5 and 6 are still shorted, because that will save me from having to scrounge. Did I even have any of that on camera? Did I even? I'm sorry, guys. I don't think I even had any of that extraction on camera. Sorry about that. You should have screamed a bit louder. Hey, dummy! Fix your camera! Where did my stupid... There it is. Okay, so let's make sure our pins are loose. Okay. Let's remove the IC. Should come right out. He says, someone's replaced this. Was it the original owner? I don't know. But I'm sure that if they replaced it and that D302 was blown apart, it would have taken this right immediately out again. There it is, right out. Covered in thermal paste that's not necessary. Alright, so we'll set that aside and we'll test our pads. We're hoping that 5 and 6 are still shorted. And if we touch our leads together, as soon as I untangle this mess. Alright, so here we go. Here's 5 and here is 6. Not shorted. Son of a bitch. Alright. So if we imagine this installed in the chassis, it's going to be... Let's see here. 1, 2, 3, 4, 5, and 6. That's interesting. That's very interesting. So it's in here like this, which would give us what's going on here then? Maybe there was some solder touching here. I guess I could have looked closer, but we got the only one that should read to the frame here is pin 5. So 1, 2, 3, 4, 5. That's 6. 1, 2, 3, 4, 5, 6, 5. 5 should be the ground. 1, 2, 3, 4, 5, 6. So pin 6 is still reading the ground. 5 is not. 5 should be the ground. That's not right. Because if we look here, ground is 5, and we don't have anything on 6. I don't think that that is correct. This is my mind going away? Have I done so many of these that I'm losing my mind? It is very possible. 1, 2, 3, 4, 5, 6. But 6 doesn't ring to 5. 5 doesn't ring to the frame, and 6 and 5 don't ring. Am I losing my mind? You know, let's grab another one here. You know what? Let me grab the chassis off of this tube I'm going to be testing with. And let's take some comparative readings. Okay, let's move this out of the way. And here is a working U5000 that I just pulled out of the tube that we're going to test with. So let's test this here. I don't think I'm losing my mind. Okay, so our leads are still good. 1, 2, 3, 4, 5. Yeah, see? I'm not losing my mind. That chip is bad. Because you can see here, I'm on the ground. 1, 2, 3, 4, 5. There's our ground. It's right there on the ground trace. You can trace it right to the heat sink. We can go to the heat sink. There's 5. And there's pin 6. Nothing. And plus, if we go to our D303, and we do negative on the right and positive. Get out of the way, all you junk. There you go. Ugh, hold on, I'm going to be in the way here. Okay, D303, one way. There's the correct way. Now if I flop my leads, it should not read backwards, and it does not. So yeah, I'm not going crazy. That chip is definitely kaput. That had me wondering what was going on there. So we got, instead of the ground pin that's supposed to read the ground, we have one of the pins short of the ground that shouldn't be, and the one that should be isn't. So something's very odd there. And I realized we should call Guinness and ask him to go back and watch this video and give me the record for saying the phrase, "That's just odd." Now that I think about it, I've probably said it about a dozen times already. And that in and of itself is not odd. So we definitely have a bad vertical IC, and that sucks because I don't think I have any. I may have to rob one from a working board, a working chassis, so I can get this back to the owner and then fix mine that I robbed it from at a later date. It may end up being what I have to do, but there's no reason at all to even put this one back in because it's definitely shot. But now, why pin 6 is reading to the back when pin 5 should be? That's what I don't understand. Let's go back and test this again here. Hang on a second. There we go. Alright, so if we just go to the frame, it's 1, 2, 3, 4, 5, 6. Yeah, see, that shouldn't be. It should be 5 should be ringing, and 6 should not be. Well, I'm sure this thing got taken out when D303 was blown up and they didn't realize it. So that's going to have to go in the garbage. And I mean, we really can't really proceed until I get a known working one in there. And I'm skeptical. Let's make sure I get this back on the black wire, the black one, which as you can see is on the setting for the medium resolution. So you can see the pin is on the side without the wire. That's how you want to have it for 25. I guess what we'll do is I'll go ahead and do the reflow here on what needs reflow, and then I'll see if I can rob a known working vertical IC. I may as well just rob it from this one that I have here that I took off the tube that I know is working, but I'm afraid that I might damage it. And I know for a fact from previous testing that if you try and power it up without a vertical IC in it at all, it doesn't like that. So I'm not going to worry about that or even attempt it. So I wanted to reflow this here for the 15 side. I think this chassis might have spent its entire life on the 25 medium resolution setting. Because the 15 side isn't really bad at all. Yeah, I thought I was going crazy there. I was like, wait a minute. Why isn't pin 5 going to ground? It should be. So let me pull. I'm going to pull the known working one out of here, and if we blow it up, hey, no big deal. I'll order 3 or 4 of them. At least I know this one's working. All I got to do is just put the new chip in when I get the new chips in, and it won't be a big deal. So I'm going to go ahead and steal this one, and we'll test it off of the board to see if I am still sane. And I think pin 5 should ring to the frame and not pin 6, and then we'll put it in here and see what we get. So for now, I'm going to go through and do a full reflow and everything off camera like I normally always do. You know, I have to fix, which one was it? I have to fix this little guy right here that is wiggle wiggle. Well, let me just do that right now. No reason not to. Let's get rid of that. What is going on here? Urgh. Why are you stuck in there? There we go. Jeez. That cap's original. Looks like original cap on there. Alright, so now what we can do is brush up quite literally on our repair. I want to take a little bit more off of here. Alright. I don't know what that is, but it's got to come out of there. That should be all right. Okay. All right. Let's grab our capacitor, put it back in. And I think that'll work. Let's see. Yep, I think that'll work just fine. If we wiggle the capacitor, it no longer wiggle, 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 wiggle. Got nothing. So I think that'll work. Okay, so I've done everything that I want to do for now. I gotta fix this here. I'll fix that later. So I'll go through and do things like this and a full reflow and everything off camera, but for now, let me rob this vertical IC out of this known good one, and we'll slave it in here. Slave it in that one, and then we'll see exactly what we get, because everything else in the circuit seems to be okay. We'll put this in here and check D303 and all that. So I'm going to cut away here, take this one out. When I come back, I'll have it installed in the other one here. Give me a moment. Alright, we are ready for testing, but there's a few things we need to go over first. Alright, so I got the new vertical IC installed, or the replacement vertical IC, and I was able to successfully mount the mod here with the screw and a nut. I mount it to the heatsink the way it should be, so now we don't have to worry about this getting loose or falling apart. So we have it set currently to the not jumpered. It's currently set to the black post. You can see the post is going in the black wire side without going to the white, so that's correct setting for medium resolution. We got everything hooked back up on the neck board and our remote board. Everything is good to go. I got all the reflow complete. I fixed the issue over here with that speaker wire. Well, I'll show you. Well, I'll just show you here. I got that speaker wire removed and got the trace scraped away and soldered right to the trace like I normally do, so that's repaired, along with that other cap that was wiggle, got that fixed. And one thing I did notice when I was inspecting and doing reflow was that someone had the wrong caps installed in the neck board here. For C501 and C502, there's three 50 volt 10 microfarad capacitors here. They're supposed to be polarized, negative this way, positive this way. Well, they had a polarized cap in location C503, but 501 and 502 they had some bipolar caps installed. They had two 50 volt 10 bipolar caps. Well, that's not supposed to be in there. They're supposed to be polarized caps. So that was problem number 5. Problem number 6 was they also had a bipolar cap in C512. C512 here is supposed to be another polarized capacitor, and someone put a bipolar non-polarized one in there. So I don't know what kind of effect that would have had on things. I don't think it would have affected our vertical collapse at all. I think our vertical collapse was obviously D302 exploded and caused a cascade failure. But in fixing and aligning all of our heat sinks and our transistors for the color and getting our resistor spread apart and getting this reflowed and inspected, I found 3 bipolar caps in place of polarized caps that shouldn't have been like that. So that's what these 3 caps are. So I got those changed. I had to raid my stash over here and find those caps. So that's taken care of. So with the reflow work done, the inspection work done, we know it powers up, or we're assuming it powers up, so I didn't bother checking the power circuit on camera. I checked it off camera, everything checked good. So we have our issue with the vertical IC still to test, I should say. So let's zoom in a bit. Alright, so if you recall moments ago, pin 5 and 6 were shorted together. Wake up. Alright, so our meter's good. If we go to pins 5 and 6, they are no longer shorted together. If I go to ground, pins 5 and 6 are both reading to ground. 1, 2, 3, 4, 5, 6. Nothing. So 100% certainty we can state that that vertical IC is bad. So, actually I didn't actually go through and check the rest. There's 5, 6, 7, 8, 9, 10. So we got a known good IC in there. Everything up to that point tests good. We'll test our D303 again. It's going to be hard to see now that I have the mod in there, but if we go here, this is the way it should be. There's our diode. If we flip our leads around and touch the opposite way, it should not read backwards, and it does not. It gives a little bit of reading there, but it's not reading backwards. So that's a really easy, quick way to tell if your vertical IC is shorted. If your D603 reads correctly the correct way, you flip your leads and it reads the same backwards or forwards, give or take, the vertical IC is definitely shot, or D603, but not likely. So you can see there, if I read it correctly, it's good, and then the other way around is also good. Well, I mean good like it's not reading both ways. So there's a good, quick, easy way to test your vertical IC, and we found obviously that it was bad by doing that. And of course, checking all the pins to ground. Only pin that should be to ground is pin 5. So we're all reflowed, and our vertical IC is good, our power circuit is good. We've tested everything else in the vertical circuit that would cause vertical collapse under normal circumstances. There could be some other crazy stuff happening, but let's go ahead and just power it up and see what we get. One more thing, I'll take a look here just to make sure nothing else looks out of the ordinary. Everything seems okay. Alright, so let me get the camera off the overhead, put my capacitors away, get all this stuff out of the way, and see what we get. I'm confident that we're going to be good. If we are, we'll count this repaired, and we'll give another overview of what we found. And I'll have to order replacement vertical ICs to fix the one that I robbed. This good one here, I'll have to order one to replace this one that I robbed it from, because this is, like I say, the one that was originally on the tube we're testing with, and it was working perfectly, so it shouldn't have any issue after I just put a new one in. Alright, let's get all these replaced. No need for you to watch this. I'll get all these back in the bag. I'll get the chassis on the tube, and we'll get ready to power it up. Stand by. Alright, so we're all hooked up, double verified, everything's connected. We're hooked up correctly on our vertical sweep selection, and our test pattern generator is set to medium resolution. We can go ahead and turn it on. And what do you think? There's only one way to find out. I have not turned it on yet. Share in the knowledge with me. Come along in the journey. Let us see what happens. 1, 2, 3. Okay, that's good. What do we have for video here? Hey, no collapse. H position needs to be drastically adjusted. There we go. Let's get the camera on the tripod before we do any... Man, someone was cranking on the focus here, because it is just a bit wrong here. Hang on, I forgot to set my tripod up. Just a bit out of whack. Okay, sorry about that. Just a bit outside. Let's adjust that down. Zoom in a bit. Alright, let's fix this focus here. Yikes. Holy cow, contrast down, brightness down. Someone was cranking on this stuff here down. Height. Full deflection. Hot diggity. H position. Width. Now, we don't quite have full width, but it goes all the way to the edge down here and all the way to the edge up here, give or take. Yep, so I think that's about as good as we're going to get it. Not a big deal. So let's turn up our contrast is too high. The rent is too damn high. So let's contrast all the way down. I don't think this has a sub brightness. I think the K7400 is the only chassis with the sub brightness, so we're going to have to tweak down on our pots a bit. There we go. Okay. Well, there you go, guys. Fixed. So it looks like we had, what do we have? A blown D302. We had a R303 out of spec. We had a bad vertical IC. And the jumper selection for 15 and 25 was on the wrong setting. So that very well could have damaged it. But there's 25. I got... I just noticed something. If you look very closely here, this little speck right there, that's on the inside of the tube. That is on the inside of the tube. Must have had something fall through when it was upside down at some point. I never noticed that before, but that is absolutely on the inside of the tube. Very interesting. Oop, wrong way. But there we have it. Can we turn red up slightly? Yep, right about there. All right. Convergence looks good. Can we do a bit better on the focus here? Oh yeah, bam, glorious. So let's try the 15 kilohertz. Let's or standard res. Let me turn this off. I'm going to turn off the test pattern generator. I'm going to swap the connector over to standard res. And let's hook up the NBA Jam. Because I like to use actual PCBs for some of this testing as opposed to the test pattern. The test pattern generator is great for what it is, but sometimes I like to use actual PCBs to get a better view of colors and stuff that I'm used to seeing, so to speak. So let's try it now. We're on 15 kilohertz. Oh, very important. Move the jumper for the vertical sweep. Okay, now we're set up correctly. Here we go. Oh, you know, I think I am going crazy in my old age. I forgot to hook up the video. From the JAMA harness, I forgot to hook up the video. Let's disconnect the test pattern generator and let's hook up our video from the JAMA harness. Okay, now. Well, it doesn't quite sound right. Nothing yet. We're out of focus too, aren't we? Yeah. Well, it's working, but... Oh, there we go. Okay, yeah, see the... and that's another reason why I really don't like using the test pattern generator. It's great for what it is, and another reason why I like using actual PCBs, because the test pattern generator, the output of that on the video circuit is like twice, double the output of a standard PCB. So you saw there that it was how dark that was. Using the test pattern generator for the medium resolution, I got the colors and brightness and everything set the way that it was working just fine. I swapped over to standard res and putting a real PCB in there, it's so much more darker. And it's because the test pattern generator has a higher video output. So that's why I kind of like using a standard board on testing the standard resolution. So let's readjust this height, vertical position, right about there, H position. See, now I got width out. I got width out the ass here. Okay, width. There's my width, vertical, or size here, brightness, contrast. Well, it's going to take a while. I mean, I'm not going to spend half an hour dialing in colors and whatnot because obviously I say it every time, this is not staying on this tube. But as you can see, it's working for 15 and 25. Yeah, it needs some adjustment here. Well, anyway, there it is. It doesn't look all that good. I can't really bring up any of the colors without it bleeding. Let's go into the test menu here. And right there is right where it needs to be, but even at that location, or this position, it's a bit too dark. But we'll have to live with it the way it is. It doesn't ultimately matter because, like I say, it's not staying on this tube. That's a bit better. There we go. That's not bad at all. Let's turn off this light here. There you have it. I think that's okay for some quick adjustments. Alright, so what do we have here? Yep, we've reviewed all the problems. Bad vertical IC, destroyed D302, out of tolerance R303, and who really knows what else is going on with this. But as you can see, it's good to go. So I'm sure the owner will be happy. I'll get it back to him. And he'll have to redo all of his colors and settings and adjustments and all that stuff. But it is working. Let's go back to 25 kilohertz now, medium resolution. Turn that back off. Disconnect the video. Swap this back to 25. Hook the test pattern generator back up. Turn it on, and here we go. Oh, forgot to swap my sweep mod connector. What's going on here? Ugh. There we go. Had to adjust. I got scared there for a minute. Had to adjust the horizontal hold. Alright, so yeah, it's working. I'm not going to bother readjusting the size and everything. That was scary. Whew. That's why it's very important. You want to make sure you get that jumper in the correct spot. Alright guys, so I've drugged this on long enough. Thanks for watching. Hopefully you learned something. And stay tuned because I got at least 5 more chassis here in the backlog. I got to order replacement vertical ICs to fix the one I robbed for this one. And lots of stuff coming here. So stay tuned, like, share, and subscribe. I appreciate you watching, and thank you very much.